Hello, boys and girls. Now we will see the today's topic. That topic is related to the oscillations, and in these oscillations, last time we have seen the simple harmonic motion, and in that simple harmonic motions we have seen the expressions for differential equation, and from that differential equations we have derived the relations for acceleration of the particle in the simple harmonic motion, velocity of the particle, and displacement of the particle in the simple harmonic motion. Last time we have derived the relation, general relation for the displacement of the particle which is performing simple harmonic motion. And we know the general relation for the simple harmonic motion is displacement equation in the simple harmonic motion is, that is, general equation of simple harmonic motion is x. X means displacement is equal to a sine omega t plus phi. Omega t plus phi. Consider this equation as equation number 1. Then in this equation, x is the displacement, a means the amplitude. What is mean by amplitude? As we know, this is the simple harmonic motion. In this simple harmonic motion, this is the mean position, and this is the one of the extreme position, and this is the another extreme position. So distance of the extreme position, distance of the one of the extreme position from the mean position, that distance is called as the amplitude of the simple harmonic motion. So this is the distance indicated by A, and this distance A is called as the amplitude. Then omega, that is the angular speed or velocity. Then phi means initial phase or state, or it is initial angle. It is initial angle. So phi means initial phase or initial state or initial angle. It means when the body or particle starts its motion from a certain position, then the state or phase or angle related to that starting point is called as the initial phase or initial state or initial angle or epoch. So T means instant to which we are going to study or observe the motion. So this is the general relation, and this general relation gives the displacement of the particle in the simple harmonic motion at any instant t. At any instant t, where the particle may start its simple harmonic motion from any position. Then the general equation is given, or for the displacement is given by this relation or equation 1. Now we will see the two basic positions like mean position or extreme positions. When a particle starts its motion from mean position or extreme positions, then the general relations we can convert into another relations for the simplicity. So for the simplicity, when the particle starts its motion from the mean position, then the relation will be different for the displacement, as well as the relations when the particle starts its motion from the extreme position. Let's see the two cases. Case 1, if the particle starts simple harmonic motion from mean position. This is the mean position. This is the starting point of the particle. That means at this position, starting point and starting time. Starting time, it will be 0. Initial time, it is 0. T is equal to 0. And what will be the displacement when the particle is present at mean position, is starting its motion from the mean position. At that position, the displacement will 0. So when particle starts its motion from mean position, then displacement will be 0, time will be 0. These two information oscillations, then place in equation 1. Equation 1 becomes displacement 0 0 is equal to amplitude A sine, then omega t is 0, means omega t will be 0, only remaining factor will be 5, means sine of phi. So 0 is equal to A sine phi, then we can consider sine phi is equal to 0, so sine phi is equal to 0, so sine of the some angle is equal to 0, means angle phi it should be 0, or it should be pi, or it should be twice pi, or 3 pi, etc. When the angle resembles one of the value at the right hand side, it means 0, pi, twice pi, 3 pi. So for all these angles, the sine of the angle value will be always 0, means sine phi is equal to 0, means phi must be equal to 0, pi, twice pi, 3 pi. Generally it is written as n pi. Generally it is 0 pi. When n is 0, we will get 0 pi. When n is 1, we get pi. Twice pi. When n is 2, we get twice pi. When n is 3, we get 3 pi. Means value of n will be starting from 0, 1, 2, 3, etc. So the phi value may be 0, maybe pi, maybe twice pi, maybe thrice pi. So then we know phi is 0. Basically consider the first value that is phi is equal to 0. This phi, that means the initial phase. That means when the particle starts its motion, simple harmonic motion from the mean position, then we can consider the value of phi, that means initial phase or starting phase or epoch. That phi we have to consider as 0. Then equation 1 gets reduces in the equation 2. X amplitude may be positive or negative. Amplitude may be, that means the extreme portion may be positive side or negative side, means plus or minus. So displacement may be positive sided or negative sided. So x plus minus a sine of omega t plus phi, but phi is 0, so sine of omega t. So this is the equation 2. This equation number 2 gives the displacement in the simple harmonic motion which starts its motion from the mid position. So let's see the second case. The case 2, when the particle starts its motion from the extreme position. So at extreme position, this is the extreme position. At extreme position, the displacement, this is the positive, maybe positive. It is a plus, and displacement at this side, this is the negative, that means the minus a. So displacement x, when the particle is at extreme position, one of the extreme position, the displacement x may be positive a or negative a. So displacement may be positive or negative a, and the time, which is the starting time. Simple harmonic motion is starting from the extreme position, means at extreme position time will be 0. So place these values, x is equal to plus minus a and time is equal to 0 in the equation 1, which is general equation. So x is a, that means plus a or minus a, which is written at the right hand side. So displacement x is a is equal to a, again a, then sine of omega t plus phi. Omega t, as t is 0, means omega t will be 0 plus phi, only remaining will be phi. So sine of phi. Here a and a will get cancelled, plus minus 1. So this will be the equation. When the particle starts its motion from the extreme position, then we get this condition: sine of phi is equal to plus or minus 1. Plus or minus 1. So sine of phi is equal to plus minus 1 means phi should be of pi by 2 or 3 pi by 2 or 5 pi by 2 or 7 pi by 2, etc. So these are the different angles for which we can get the value of plus 1 or minus 1. So select the initial value phi, which is pi by 2. Place this phi is equal to pi by 2 in this equation 1. We get okay, pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2. Pi by 2 is common in all. Pi by 2 is common. Then 1, 3, 5, 7, 9, 11. Such numbers we will get, which are the odd numbers. Means here generally this value or this information we can write here phi is equal to odd integral multiple of the pi by 2, pi by 2, pi by 2, pi by 2. So odd integral multiple of pi by 2 means odd number is indicated by n, again pi by 2, where here n is equal to 1, 3, 5, 7. These are the odd numbers. So this, now select the first value. Phi is equal to pi by 2. Place this value in this equation 1. Then this equation will get reduced in this way. So equation 1 becomes x is equal to a sine omega t plus phi. But phi means pi by 2. Right here pi by 2. Omega t plus pi by 2. So sine of omega t plus pi by 2 becomes cos of omega t. Sine omega t plus pi by 2, it becomes cos of omega t. Here so x is equal to a sine omega t plus pi by 2. Pi by 2 means phi, and x is equal to plus minus a sine omega t plus pi by 2 means cos of omega t. Equation number 3. So this is equation number 3 gives the displacement of the particle in the simple harmonic motion which starts or initiates from the